All right, so yesterday we talked about solving quadratics, and we used factoring, big X, GCF, that kind of thing. Today we're going to talk about a different method that you can use, which is taking square roots, right? First thing I want to talk about is when you would want to do this. So as you look at these problems on this page, remember yesterday we talked about that the standard form was ax squared plus bx plus c. Now, something ought to stand out. There should be a plus sign there. Something ought to stand out about any and all of these. Anybody see it? If I were to solve this one, if I were to rewrite it so that it would be v squared minus 64 equals 0, right? Subtract 64 on both sides. What do you notice about this compared to the standard form up here? Something's missing. Anybody see it? I've got the x, I mean, we're not using x, obviously, but I've got the squared term, and I've got the constant, which would be the c, but what about this middle piece? I don't have any piece that just has v, right? And if you look at these other examples, kind of as I go through here, they all seem to be missing that b term. And a lot of times, if you're missing that b term, that can be a good hint that you might want to use the square root method, okay? Now, I'm going to do this first problem two ways. I'm going to factor it, and then I'm also going to do it by the square root method. And then for the rest of them after that, we'll just talk about the square root method, okay? So
you can actually do it both ways?
Sometimes. So this one is a 64 is a perfect square, right? So that we should recognize that as a difference of perfect squares, right? Okay, which means I can rewrite this as v plus 8 and v minus 8. This will be kind of how we did it yesterday if we had a difference of perfect squares. And so then I take each one of those factors and do what with it? If I'm trying to solve.
You would set them equal to 0.
Set each one equals 0, right? So v plus 8 equals 0 and v minus 8 equals 0. So then once I solve that, I get v equals negative 8. And then on the other one, I would add 8 to both sides. I get v equals 8. So what you notice there is the answer is negative 8 and positive 8. And anytime you have a difference of perfect squares, that's how that's going to work out. Okay? But there's another way we can do that same problem. So if I think about it the way it was originally written, v squared equals 64. If I want to solve that for v, how do we undo a perfect square or something to the second power? What's the inverse of squaring something? No? Nobody? Square root? Yeah. Remember Pythagorean theorem and all the times we've done that? Remember all this square root stuff we've done in this class? Come on now. So if I take the square root of both sides, okay, the square root of v squared, what happens to that squared and that square root? They cancel each other out, right? So that leaves me with v equals. Now, anytime you take the square root of a number, right, what's the square root of 64? 8. The only thing that we need to remember is, since it's the opposite of squaring it, there are actually two numbers that you could square to get 64. Positive 8 and negative 8, because negative 8 times negative 8 is also a positive 64. Does that make sense? So anytime you take the square root of a number, you need to realize that the answer to that is going to be positive or negative, right? It's the positive and the negative. There's two possible answers there. So again, that means v equals 8 and v equals negative 8, which are the exact same two answers that I got when I did it by factoring. Does that make sense? Now, going back to what Adam was saying, can we just do them both ways? If they both happen to be perfect squares, then yes, you can do a difference of perfect squares and factor it, or you can do the square root method. Either way would work. Adam, if it doesn't work out to be a perfect square, then you won't be able to factor it, but you still could potentially do the square root method. Okay? So most of the ones we'll do today could be done either way, but we're going to focus on doing the square root method. Okay? So here's the deal. If you're going to do the square root method, basically what you want to work towards is your variable squared equals a number. right? So all these problems are going to try and get set up like that. Now 1 and 2, we don't have to do any work to do that. They're just automatically set up where I can just jump straight into taking the square root. So square root of both sides. Square root of b squared is b. And the square root of 9 is plus or minus 3. So your two solutions here is b equals 3 and b equals negative 3. Okay? And that's a lot quicker. Like, being able to do that is a lot quicker than trying to move that term to the other side and rewrite it as a difference of perfect squares. So this is just quicker if you see that you can do it this way. All right, any questions so far? All right, slide down to number 3. Now, what's keeping us from doing this square root method on this problem straight off the bat? Do we have the v squared on the side by itself? No, we got that 9 on that side with it. Could I easily move that 9 to the other side? Yeah. How would I do that? So subtract 9 on both sides. And that's going to give me v squared equals 81. Now, we go right back to that square root method. Does that make sense? So square root, and that's going to give us v equals plus or minus 9. All right. For the time being, or for the sake of time, I'm not going to keep writing it as v equals 9 and v equals negative 9. Please understand, if you see that plus minus in front of a number, that means there's two solutions, right? One positive, one negative. Okay? All right, how about number 4? That negative in front of that v is a problem. Okay? But that's an understood what kind of negative? It's an understood what? Numerically speaking, what number would that be? Negative 1. So if I understand that's a negative 1, then I can divide, because that's multiplication, right? Divide by negative 1 to begin with. And when I do, I get v squared equals positive 16. And now we're right back to where we just were. Square root both sides. Okay, so if I can get the variable squared equals a number, then I can do this method. If you can't get that, then this method probably doesn't work. Okay? All right, so we end up with v equals plus or minus 4. All right? Any questions about that? Okay, as you can tell, as we move down the page a little further, they're getting a little bit more complicated, right? All right, so tell me about number 5. Is the n squared is not by itself, is it? Okay, but this time we got two things over there with it. We have that plus 5 and we have that multiplication of 9. Which one of those do we have to move first? We have to undo that plus 5 first. That's what we're going to do. So subtract 5. That leaves me with 9n squared equals 149 minus 5 there would be what? 144. Thank you. All right, and then what's going to be my next step? Divide by 9. All right, somebody with a calculator, help me out here. What is 16? Yeah. Perfect. Thanks, sir. All right, now we're right back to that step where we can do what? Take the square root on both sides. Okay? Y'all go ahead and do number 6. I'm gonna give you like 2 minutes or less. Go ahead and try number 6 on your own. All right, so the first thing you should have done is added 1 to both sides. 6n squared equals 96. Did everybody get that for the first step? Next step would have been to divide by 6. That leaves you with n squared equals 16. And then now we're at the step where we can take the square root of both sides. And that would have been n equals plus or minus 4. Okay? So I think this is a pretty easy concept. It's pretty easy mathematically for y'all to do. The only thing you have to be careful of is knowing when to do this versus when to factor. And the key is if you're missing that b term, right? If you're missing that x to the first power or whatever variable you're using, right? If you're missing that middle term, the middle term up here of our problem, then we can probably take the square root of both sides. Okay? Also, you cannot take the square root of a negative. So if you ever had like, this is a completely made up problem, but if you had v squared equals negative 16, you could not square root, but that doesn't work. That's something else entirely. Okay? Matter of fact, you wouldn't be able to factor that either, so that's just a whole different ballgame. All right? So just in case you saw something weird like that, but you shouldn't see something like that from us that we've created. All right, at least not this year. All right, these last two problems, they're kind of unique. How are these a little bit different? Is it just the variable that's being squared? Is it just the variable here that's being squared? No, it's a binomial that's being squared. Okay? Does that mean that we can't still take the square root of it? We absolutely can. So in this scenario, you start by taking the square root of both sides. Square root of that, what does that really mean? What does this mean? X minus 2 squared. What does squaring something mean? You multiply. There's two of them, and you're multiplying them together, right? So this really means x minus 2 times x minus 2. Yeah? So if I take the square root of that, remember how if we had a pair underneath, we could cross one out, bring one out? Remember us doing that with the numbers? Same thing happens here. So what we're left with is the square and the square root undo each other, and you're left with x minus 2 equals, now when I do it here, square root of 25 is what? 5, but be careful here because if you do it to just a number, it's plus or minus that number. Could be the positive or the negative 5. Now, I cannot leave this answer like this. I've got to do more. Okay? So, we need to break it up. We have x minus 2 equals positive 5. And we have x minus 2 equals negative 5. Now what would I do to finish solving? I still want x by itself, right? So I need to get rid of that minus 2. How are we going to get rid of that minus 2? Add it. That's right. So plus 2. Do it to both sides. All right. So we end up with x equals 7. And x equals, now negative 5 plus 2 is going to be negative 3. How could you check to make sure that answer was correct? Or both of those answers are correct? Plug them back in, right? So let's think about that. So if I did 7 minus 2, that'd be 5. And then if I squared that, 5 squared is 25. So that works. If I did negative 3 minus 2 is negative 5. If I square negative 5, I get positive 25. So that also works. Does that make sense? Okay. Last one. Let's talk about number 8. Can I take the square root of it? Is the squared term on the side by itself right now, or is there something else attached to it? That 2 is out front, right? We're not squaring the 2. We're only squaring the stuff that's in parentheses. So I need to get that stuff in parentheses on the side by itself in order to do the square root. So what can I do with that 2? Ooh, can't distribute because this means that's squared. If it was just that times 1, yeah, you divide it, right? Because it's 2 times all of that. So that means I can just divide both sides. by 2. And that leaves me with x plus 3 squared equals 16. Now what would be the next step? Now we can take the square root. Okay? And I'm going to get x plus 3 equals plus or minus 4. And then I need to now actually break it up so that I can get rid of that plus 3. So I have x plus 3 equals 4 and x plus 3 equals negative 4. And then what would I do to finish each one of those up? Subtract that 3. Perfect. Do that on each one. So I end up with x equals 1 and x equals negative 7. And if you are unsure whether or not you did everything correct, to make sure you got it right, you should take those and plug them back in. Make sure it gives you the correct answer. Questions about that? Alrighty.